Today we are going to start our topic related to dynamics. And dynamics is basically, we can say, branch of mechanics in which we study the motion, study of motion with discussing its cause. Its cause is called dynamics. And if I go towards the basic unit of cause is that is force, which is force is it is a phenomenon of push or pull. It can change the direction of motion. It can change the direction of motion, and it can change the shape of a body. It can change the shape of body, and it can change the shape of a body, and it is vector quantity. mm, Vector quantity having both magnitude and unit over there. Its unit is its SI base unit is SI base unit is kg meter per second square, or SI unit is Newton. And if we go the vectorial sum of the forces over there, let's suppose I am taking two forces over here, then as vector, they will be obtained their sum over there. For example, the second force is here like in this form, and I am taking this force exactly to be added here in this form. Then this is my resultant force for it, which will be obtained by adding both of these forces as a net effect over there. This is my force F1. This is my force F2, also equal to F2. And I'm getting F over there. Then the resultant of a force has the combined effect of all added forces over there. And this is basically head to tail rule, in which the head of last vector is joined with the tail of first vector. That is called head to tail rule in vector addition over there. Head to tail rule. It is a rule the rule in which head of last vector is joined with the tail of first vector to get the resultant. To get the resultant vector. is called head to tail rule. This is also being taken in the form of parallelogram law, but right now I'm getting this according to head tail to tail rule over there, that the force one, force two are being added, and then these are the two vectors there having this direction, and I am getting them in the form of resultant F is equal to F1 plus F2 by using head to tail rule, by giving a proper scales, like how many centimeter are representing the how much Newton force over there, can be taken into account. So head to tail rule and resultant forces should be taken into account. Always remember, in scalars and vectors quantities, whenever you are going to do that, head to tail rule must be followed to get the resultant over there. After that, we will have to move towards vectors and forces into their components in according to 2D and 3D plan over there. 2D plan, not 3D, only 2D plan over there. Let's suppose I'm saying that there are forces which are acting. There is a force which is acting and available over here to show its value over here. Then we can say it is a force along x-axis and y-axis to be resolved into its components. It is x-axis, and force along it is should be taken as this is fx, this is f, this is fy, and this is the angle which is available over here along the forces. So it is x-axis, it is y-axis, it is y dash, it is x dash over there. If I take the resultant of this force into its main force over there, I want to take force as its magnitude form, then I will say the force magnitude will equal to fx square plus fy square root. If I want to take the direction of force, then I will say it is tan inverse fy over fx. On the other end, if I want to calculate its horizontal and vertical component, then I will say fx is equal to f cos of theta and fy is equal to f sine of theta. And the force along x-axis, along y-axis can be taken into account to get the resultant force over there. In mechanics, mathematics paper, we will also study about adding too many forces and getting the equilibrium position over there. We will also discuss about that. But right now, we are discussing here with the forces according to the dynamics and physics over there. So in detail, I will go now the force application over there, in which I will say here that the force is basically directly required to three main stages. That is, for example, if a car is moving on the road, then on horizontal road, right? Horizontal road, if car is going on, what is the forces which are being applied over there? Then I will say here, there is applied force, which is equal to accelerating force and resistive force, or force of friction provided by the roads over there should be taken. So force applied by the engine is always equal to force accelerating and force of friction. When you are saying that you are moving with the constant velocity of 200 meter or 300 meter speedometer of your car at its maximum velocity, then velocity is not changing. Means we can say here delta V equals to 0. It means change in velocity is 0. It means acceleration is 0. It means accelerating force is equal to 0. So your car is going in fourth or fifth gear over there. Then applied force is just exactly equal to force of friction. Very light force is required to reduce the friction between the we can say tires and the road over there. And tires are showing the rolling friction, which means very low number of cold welds or contact points between the tire and the road over there. So that will be negligible, and that will equal to force of friction over there. If I talk about force of friction in that case, then we will use coefficient of friction and something else that we will use in we can say our mechanics mathematics paper M1 like that. Okay, now I am moving towards Newton's law of motion over there. Newton's laws of motion. Newton laws of motion are basically uh, representation or application of forces in different scenarios over there. Number one is Newton's first law is called law of inertia, in which I can say inertia, what is basically inertia is? Inertia is property of body, property of body due to which it resists any change in its state of rest or motion. That is called inertia. It depends upon mass. It depends upon mass of body. And law of inertia states that a body continues, or Newton's first law, a body continues its state of rest or motion until no external force acts on it. This is called law of inertia or Newton's first law. And for example, here, if I want to state, for example, some table is lying on the floor, it will continue its state of rest until someone is going to disturb it. And for example, on the other end, in motion, for example, you are sliding over the glacier and there is no resistance. And if someone is not supporting you with the rope or something like that, you are not going to stop. So a body continues its state of rest or motion until no external force acts on it is law of inertia. At number two, it is said that, for example, Newton's second law, if I'm going towards that, Newton's second law of motion. Then I will say here, for example, there is a body of mass m and you apply a force F on this body and body is producing an acceleration in the direction of force, then we can say this produced acceleration is directly proportional to applied force and inversely proportional to mass of that body, inversely proportional to. If I join both of these relations over there, then I will say A is directly proportional to F over M. And from here, for removing this proportional sign, I am introducing a constant over there, Kf over M. Then F is equal to Kma. If I am applying that force is 1 Newton, then acceleration produced in that body is 1 meter per second square, and mass of that body is 1 kg. By applying all of this scenario, I get this value of k as equal to 1 over there. Then I say F is equal to ma. So this is the Newton's second law. which should be given a proper statement, because sometimes if he asks in exams, define Newton's second law or what is Newton's second law, for 1 mark, you can write only formula and skip it. If it is giving for 2 marks, then you will also have to give the statement over there. And for that purpose, I will say here, when a force is applied on a body, when a force like F is applied on body and body travels uh, in the direction of force, in the direction when a force is applied on body of mass m and body travels in the direction of force with the acceleration a, then this produced acceleration is directly proportional to, then this produced acceleration is directly proportional to this produced acceleration is directly proportional to applied force and inversely proportional to mass of that body. Over there, this is called Newton's second law. And if I am going to define from here a Newton, what is Newton? 1 Newton force, what is that? If a body of mass 1 kg travels with acceleration ELERAT, acceleration 1 meter per second square, then applied force will be 1 Newton. Then force will be 1 Newton. Like F is equal to MA. M is 1 kg and A is 1 meter per second square. Then the force is 1 Newton. According to its definition, Newton should be taken as a vector quantity and later on will be stored for this purpose over there. In the last for today lecture, I am going towards Newton's third law of motion. Third law. It states that every action force has its reaction equal in magnitude but opposite in direction. For example, I will say here as in the simple form, I will say book lying on the table, book lying on table, or a man sitting on table, sitting on chair, man sitting on chair. In both cases, weight is acting downward and up thrust provided by table or chair is acting in upward direction. Both are equal in magnitude but opposite in direction and canceling out each other effect over there. Tomorrow we will move towards mass, weight, and density, and also pressure over there. And we will talk about momentum also. So in the next lecture, we will talk about mass, weight, momentum, law of conservation of momentum, like that, elastic and inelastic collision, and pressure and density. We will talk in the next lecture over there. So thank you so much for today, and kindly subscribe my channel and share my videos with your friends. Like, share, and subscribe the channel. Thank you so much for today. Allah Hafiz.